Hello, today we're going to go through some questions off of the Module 5 review. Remember that these Module 5 or the module reviews can be found on our Canvas homepage, and you'll see all the different reviews there, and also there's the solution keys for it as well. So it gives you the answer, but it doesn't show you how to work through the problems. So I'm going to work through some of the problems off of this Module 5 review. So it's the Module 5 and Module 6 review. You can see I have it up over here, and that's what we're going to be kind of looking at today. So, we're not going to go through all of them, but we'll go through a good mix of them to make sure that you're feeling comfortable with the things that you need to know for Module 5. So let's start off. So we'll do some off of 5.1, and so notice how it says what, section it's from and everything. So we're going to start with number 2. So number 2 says that it wants us to simplify that expression, right? So remember that we got to use the properties of exponents in order to simplify this expression. So let me rewrite it over here. And so you can see that these are being multiplied together. And so we need to think back about our properties of exponents. And when we have things that are being multiplied together, then that means that we need to add our exponents with one another. So the coefficients out in front just multiply by each other, because that's just saying 2 times 3. So 2 times 3 is 6. And then let's go move on to our x. Our x is here, so x to the 4th times x to the 2nd. We're going to add those exponents together, and so that will give us x to the 6th power. Then we'll do our y's. All right, so y to the 10th times y to the 9th. Add those together, we get y to the 19th. And then the second factor here does not have any z with it, so we're just going to go ahead and write z to the 8th power as part of our answer, because there's nothing on the other one to combine with it. So that would be our simplified answer, getting all of those terms together. All right, let's move on to number 6 now. So number 6, let me change the page over here so you can see it. So number 6, we have something connected by division there that we're going to be simplifying this time. So let me write it here. So again, our instructions are to simplify. And we have 21 x to the 11th, y to the 12th, over 39 x to the 8th, y to the 7th. Right, so just like we combine the things together that were similar in number 2, we're going to do those same things here on number 6. So let's first look at our number part, right? So we're trying to reduce this fraction is what we need to do to simplify it. So if we reduce this, we can see, well, 3 will divide in to both of those numbers. So 3 divides into 21 7 times and into 39 13 times. So I'll have 7 on the top and 13 on the bottom. All right, and make sure that's all the way simplified. Now we're going to look at our x terms. So x to the 11th divided by x to the 8th. So when these are connected by division, we subtract those exponents, or another way you can think of it is, it helps more when we have negative exponents. We'll get to those in just a second, but thinking about, okay, where are there more x's? Because that's where the x is going to end up. So there's more x's on the top, right? So I know the x's are going to remain up here. Well, how many more are there? Well, if we subtract those, we see that there's 3 more. So x to the third is on the top. All right, then let's move to our y's and simplify these kind of the same way. All right, we have 12 on the top and 7 on the bottom, so that means there's more of them on the top, so our answer is going to, our y is going to remain on the top. And how many more are there? Well, 12 minus 7 is 5. And so this becomes our simplified answer. All right, we have everything together. We've got our fraction simplified, and we've got our x's and y's all in the same place, all together there. All right, let's move on to number 8. Okay, still simplifying these expressions here, using these properties of exponents to help you do that. So with this one, we have 5 times y to the negative 15th power. Okay, now I want to make sure it's clear that this is saying 5 times y to the negative 15th power. And you need to think about that 5 separate from the y to the negative 15th power, because remember up here on number 6 how we kind of, dealt with the whole number parts, then each of the variables separate. So we've got to kind of think about these separate. So one of the most common mistakes that's made is sometimes people think that this negative 15 is on that whole thing. So meaning this is not the same thing as 5y all raised to the negative 15th power. Right? This means something different. So make sure you notice if there's, parentheses there or not. Just the y is being raised to that negative 15th power. All right, so when I write this out, that negative exponent is telling me that I'm going to be flipping this. And so negative exponents don't mean we're going to have negative answers, but you're actually taking the reciprocal of those of that variable there. So on this one, 5 is perfectly happy on the top. All right, it's not raised to a negative exponent, so it's going to stay on the top. But y is to a negative power, right? So that means it's unhappy. It's not happy upstairs, so it wants to move downstairs. Right? So that y to the 15th is going to move downstairs, and then it will be positive. And now it's happy, how we want it there. All right, so that would be your answer, 5 over y to the 15th power. All right, let's do some more with negative exponents, because that tends to be the place where most people have problems on these type of questions. So let's go to number 13. Let me scroll this down a little bit more. And remember, I'm working through some of these, but you should work through all of these on the review. The ones that I'm working through should help you be able to do the other ones, but make sure that you're working through all of them. Right? That's going to help you get ready for the quiz and also for the final exam. All right, so number 13, because this one doesn't have negative exponents, but the next couple will. But let's do this one, make sure that we know what to do here. Okay, so again, our directions are to simplify. In one parenthesis, I have 3a to the third, b to the second, c to the fifth, and then that whole thing, right, is raised to the second power. Then in my other parenthesis, I have 2, a to the fifth, b to the fourth, c to the second, all raised to the third power. So on ones like this, when you see a power on the outside of the parentheses, you want to make sure that you're distributing that through to everybody inside, right? And so one common mistake that's made is people will remember to give that power to the A, to the B, to the C, but they forget that you also have to give it to the 3, right? So let me show you what I mean by this, right? So when I am writing this down, let me try doing a couple of different colors here. So I'm doing 3 to the 2nd power, right? I'm going to write it down like this, then I'll simplify it in the next step after that. And then I'm going to have, my next one's going to say a to the 3rd, all raised to the 2nd, right? So a to the 3rd, all raised to the 2nd. Then my next one is b to the 2nd, all raised to the 2nd. And then my c is c to the 5th, all raised to the 2nd. Right? And let's do the same thing now, distributing through this power of 3, right, to everybody inside this parenthesis. Right? So giving it to everybody in there. So this is all going to be multiplied by, so let's do 2 to the 3rd power. Right? Then we'll have a to the 5th power, all raised to the 3rd power, right? A to the 5th raised to the 3rd. Then let's do our b's. So b to the 4th raised to the 3rd. And now we'll do our c's. Our c to the 2nd raised to the 3rd. Okay, so now let's simplify each of these different parts. And as you're working through this, you might not have to take this step every time. You might be able to see, what to do and skip that step and kind of do it in one. But I just want to make sure everybody is with me and understanding how I'm getting these numbers. So 3 to the 2nd power means 3 times 3, so that's going to be 9. A to the 3rd power raised to the 2nd power. So when it's a power raised to a power, we multiply those exponents together, right? Which is, remember here, a common mistake is people try and do 3 times 2. Well, you're not doing 3 times 2, you're doing 3 to the 2nd power, 3 times 3. But when you have a power raised to a power, that's when you multiply those exponents together. So that's going to give us a to the 6th power. All right, then let's simplify here. B to the 2nd raised to the 2nd is b to the 4th, because we're multiplying those together. And then we'll have c to the 10th. All right, and now let's simplify this other one over here also. So 2 to the 3rd power means 2 times 2 times 2, which is 8. And then a to the 5th raised to the 3rd, we're multiplying those exponents together, so a to the 15th. Then we'll have b to the 12th and c to the 6th. Okay. And we're not done yet because we still need to multiply these all together. We've got to simplify it by getting the things together that are the same. All right, so that's why I kind of did these in different colors so we can kind of see what needs to be combined together. So we'll first start off with our 9 times 8. So when we multiply those together, we get 72. Then let's do our a's. A to the 6th times a to the 15th means that you're adding those together, right? 6 plus 15 is a to the 21st power. All right, now let's do our b's. And with that, we're going to add those exponents together. So 4 plus 12 is 16. And then our c's are going to be c also to the 16th power, 10 plus 6 to the 16th power. All right, and then we can tell that it's all the way simplified because we have our numbers in one place, we have our x's all together, our a's all together, our b's all together, and our c's all together. All right, so that's how we can tell that we have it all done. So that would be our answer. Okay. All right, let's do another one with negative exponents. I said we were going to do some of those. So let's look at number 16 now. All right, actually let's do 15 first. I think 15 would be a good one to look at. So 15 says 7, a to the third power, b to the negative fifth, over 7 to the negative 1 power, a to the negative fourth, and then b to the second. Right? So when we have negative exponents, remember, like I said above, we want to flip those to be where they're going to be happy, right? If they have a negative exponent, they're unhappy. We want to flip them to where they're going to be happy. So let's look and see what we have here. 7 is perfectly happy upstairs, so 7 is going to stay upstairs. Right? A to the third power is also happy upstairs, so we're going to keep a to the third up there. Right? Now b to the negative fifth, not happy, right? And so that means that one wants to go downstairs. So we'll have, I'm going to flip that downstairs, and that will be b to the fifth power down there. And now it's positive, now it's happy. And let's look at the bottom where these need to flip to. So we've got 7 to the negative 1 power, not happy. Let's flip that one upstairs. So then you have to the 7th power, or 7 to the first power, right? All right, which is just 7. Then a to the negative 4th power is also going to flip upstairs, which will give us a to the 4th power. And then b is perfectly happy downstairs, so it's going to stay down here, b to the second. Right? And now we just want to combine the things together that are the same. Right? So our whole numbers, that's 7 times 7 is 49. We've got a to the third times a to the fourth, right? So these are going to be added together. That will give us a to the seventh. And then we'll add the b's together on the bottom, which will give us b to the seventh. Right, and so that will be our answer, 49, a to the seventh over b to the seventh. Put everything together now. All right, so just remember when you have negative exponents, right, I'm going to try and flip them to where they're going to be happy. All right, let's do number 16 now. Number 16 has a lot of negative exponents in it. So if we simplify this, it says 3 x to the negative fourth, y to the second, and then that whole thing is raised to the negative third power. All right, then on the bottom, we have in parentheses x to the fifth, y to the fifth, z to the fifth, all raised to the negative third power. All right. So there's a couple of different places that you could start on this to get it all simplified. And so don't think that, you know, because maybe you start in a different place than somebody else that you're doing it incorrectly, because that's not the case. You could start by distributing that negative third power to everybody, but I find that students tend to make a mistake when they're trying to distribute like this negative third power to that 3. And so I would encourage you to try and do something a little bit different here. Okay, so let me show you what I mean. So since this whole top here, right, all of this is being raised to a negative exponent, I could put all of that downstairs. Right, so let me make my little fraction here. I could put that all downstairs, and then this outside exponent would now be a positive 3, but the stuff inside still stays the same. Right, so inside I'd still have 3, x to the negative fourth, y to the second, but now this negative 3 on the outside becomes a positive 3. And then you don't have to worry about that negative exponent. Okay, so kind of the same thing. We're going to look at this bottom, right? And just how this is written here, we're now going to take that and put it upstairs. And that will change our outside exponent to a positive 3. So we'll have inside the parentheses the same thing, x to the 5th, y to the 5th, z to the 5th, but now it's raised to a positive 3rd power. All right? So this way we have those exponents on the outside are now positive instead of negative, and oftentimes will cause less confusion for students. So it's just one way you can do this. Now I'd want to, get rid of my parentheses by giving everybody inside that power of 3. So let's do that on the top. All right, so with my x's, right, I have, so x to the 5th raised to the 3rd is going to be multiplying those together, so that's x to the 15th. All right, then my y's, y to the 5th times 3 is y to the 15th, and then z to the 5th raised to the 3rd is z to the 15th. All right, so now we don't have any parentheses there. We got rid of those, which is part of simplifying this, is making sure we don't have any of these parentheses left in there. All right, now let's go ahead and do the bottom part here. All right, so the bottom one, we have 3 to the 3rd power. All right, so 3 to the 3rd power. And then let's distribute that 3 to our x. So we've got x to the negative 12th power, and then y to the 6th. All right, we're just multiplying those exponents together. And now we're going to simplify what we have here, right? Remember, if we have a negative exponent, it wants to go to where it's going to be happy, right? So this x to the 12th really wants to come upstairs. Right? And so that's going to, when it moves up there, we're going to have x to the 12th times x to the 15th. Right? It's going to move up here. So that will give us x to the 27th. Whoops, wrong color. Try this again. All right, so we'll have x to the 27th. And then our y's, now look at here, right? There's more y's on top than there are on bottom. And so we know that the y's are going to end up on the top. And again, you're asking yourself how many more, or if you do 15 minus 6, that will give you 9, so y to the 9th. And then we still have that z to the 15th. We don't have anything to combine with it. It's still on the top. Right? And then we still haven't used that 3 to the 3rd power. And so that guy is still on the bottom. And 3 to the 3rd power is 3 times 3 times 3. And so that's 27. So this is what you'd end up with. X to the 27th, y to the 9th, z to the 15th, all over 27. And again, we know that it's all the way simplified because there's no negative exponents, there's no parentheses, and all of our x's are together, our y's are together, our whole numbers are together, right? Everything is in one place there. All right, so that was kind of a crazy one, right? It had a lot of different negatives, and a lot of the properties of exponents were in that one. All right, so that was 5.1 and 5.2. I kind of did those together since both of those sections dealt with properties of exponents. So let's move on to do a few problems off of 5.3 now. All right, so in 5.3, let's see, it's where we're talking about some scientific notation. And so we got to make sure we know how to write numbers that are whole numbers, right? Or I guess just numbers in standard form, I should say, in scientific notation, and the other way around. Right? You need to be able to make sure you can do both directions there. So let's look at number 17. Number 17 says that we're going to take the number 59,000 and write it in scientific notation. Well, remember with scientific notation, we said that our decimal on this number in standard form is at the very end of it. It's furthest to the right there. And we need to move that decimal so that we have a number that's between 1 and 10. And so it has to move between that 5 and the 9 to give us 5.9. Right? If we left it here, one before it, then that would be 59. And 59 is not a number between 1 and 10. So we've got to make sure that we have it there. All right, so we're going to have our number in scientific notation is going to be 5.9. And then you're always going to write times 10 to the something power. Right? Well, since this number that we started off with was a number that was larger than 1, then we know our exponent on here is going to be a positive exponent. And so then we just need to look at how many places did we end up moving that decimal point. We moved it 4 places. So this number in scientific notation would be 5.9 times 10 to the 4th power. Right? And if we started off with a number that was smaller than 1, kind of like we have here on number 18, right, then we know it's going to be times 10 to the negative something power. And that's depending on how many places we move that exponent, or that decimal point again. All right, but let's go down to number 20. And on number 20, right, we're going to take a number that's already written in scientific notation, and we're going to change it to a number in standard form. Right? So with this one, all right, this negative 2 exponent is telling us that we are going to move our decimal 2 places to the left. So my decimal point is here. I need to move it 1, 2 places over. So that means I now have my decimal point here, and I've got to put a 0 in place there. So I'll end up with 0.0, right, if I put a 0 there, 882. And that would be my answer in standard form. Okay? So making sure that you know how to take a number, write it in scientific notation, or take scientific notation and then write it as a standard number. All right, but the next part of what we talked about in 5.3 was what if we have some scientific notation that's being multiplied together or being divided, what we do with those. So let's do number 21. And 21 says it wants you to multiply these together and then make sure your answer is in scientific notation. So in one parenthesis, I have 4.7 times 10 to the 8th power. And then that's going to be multiplied by 1.5 times 10 to the negative 20th power. Right? And so you can kind of think of these as your, kind of like what we were doing with properties of exponents. So we're first of all going to make sure that we multiply the whole number parts together on that. Right? So when we multiply 4.7 times 1.5, we get 7.05. Right? And then we've got to do the rest of it here, where we're going to look at the powers of 10. Right? So now on this one, we've got 10 to the something power and 10 to the something power. So we know our answer is going to be 10, right, times 10. And then since it's connected by multiplication, that means we're adding those exponents together. So 8 plus a negative 20 is going to give us a negative 12th power. So our answer would be 7.05 times 10 to the negative 12th power. And this is in scientific notation. Now, one thing that you need to check for to make sure it's in scientific notation, remember, is that this number out in front is a number between 1 and 10. If it's not, you've got to change that number, right? Move your decimal point, and then that will change what power this is being raised to. So let's look at number 24 now. And on 24, let's see what happens here. So I know this one's connected by division. All right, so we have on the top 2.64 times 10 to the third power over 5.5 times 10 to the negative 15th power. Okay. So again, we're going to start off by just dividing these numbers. All right, so go ahead and in your calculator you can figure out what's 2.64 divided by 5.5. And that's going to give us 0.48. Right, 0.48. And then on our powers of 10 here, right, we're doing 10 to the third power, and remember when they're connected by division, we're subtracting those. So I'm going to do a little work down here. So this is really saying 10 to the 3 minus the negative 15th power. Right? So when you're minusing a negative, you're really adding those together. So that would be times 10 to the 18th power. Okay. But now we need to look at this and say, is this in scientific notation? Is this number that I have here in orange, is that a number between 1 and 10? And it's not. This number is smaller than 1. And so we need to move that decimal point, right? And so we need to move it over one place to the right. And when we do that, that's going to change our power here, and it's going to make it 1 less, right? Because we're thinking about this, right? I'm kind of moving back, right? It's going to change it to 1 less there. So that means our final answer would be 4.8 times 10 to the 17th power. And that's the way you'd want to have your answer written. If you leave it like this, you will miss some points on tests and quizzes and stuff. It's got to be in scientific notation, so that first number, that number out in front, has to be a number between 1 and 10. All right, well, I think that's good for 5.3. Let's go and look at some of the things that we learned in 5.4, where we were talking about some square roots on 5.4. Right, and so 5.4, let's do number 28. So it wants us to find the square root of negative 25. It wants us to simplify this, right? And so really what this is asking us to do is saying find a number multiplied by itself that would equal negative 25. Right, so what number times itself, right, would give us a negative 25? And so if you think of some options here, some people are like, oh, I think maybe it's negative 5. But if you do negative 5 times negative 5, that doesn't give you a negative 25 because negative times a negative gives you a positive answer, right? So that doesn't work. And if we tried to do 5 times 5, that would still give us a positive number. And so there is no number that I can multiply by itself to end up with a negative answer. So that means that I cannot take the square root of a negative number and end up with a real number. So we're just going to say here that it's not a real number. And then later in math, you'll talk about imaginary numbers and how when you have negatives inside square roots, you're going to be using the imaginary number system. But right now, we're working in the real number system. So we cannot find an answer for that in the real number system. So it's not a real number. All right, let's look at number 30, also in 5.4. All right, so number 30 wants us to figure out what's the cubed root of negative 216. All right, well, when we have a cubed root and we have a negative number inside, we can find the answer to it. Because this, all right, when you have, and think about when you have a negative times a negative times a negative. So again, we're thinking of what times what times what is going to equal negative 216. And these numbers inside here have to be the same number, right? And so, and most of your calculators will do this. And so if you put it inside your calculator like this, you'll see that the answer is saying negative 6. And that just means that negative 6 times negative 6 times negative 6 is going to give you a negative 216, right? And so that means our answer is negative 6, right? What number, if you multiply it together 3 times, gives you a negative 216, right? Well, that would be negative 6. Negative 6 is our answer there. Okay. All right, let's look at, let's go to 5.5 now, because 5.5, we have to, there's more simplifying that has to be done. And this, in 5.5 is where we kind of get into some variables inside the square roots also. And we're also going to be dealing with cubed roots and fourth roots and stuff like that as well. All right, so on 5.5, let's look at number 32 to begin with. So we're asked to simplify the square root of 320. All right, now 320, if you try and put that into your calculator, you're going to get kind of this decimal answer for it. But we don't want our answer in decimal form. It wants us to keep our answer in radical form. So the way that we go about doing that is we're going to find the prime factorization of 320 by making a factor tree. All right, so we're thinking what times what gives me 320? Well, since it ends in a 0, I know it's going to be 32 times 10. And then I want to break these down, right, to be all prime numbers. So I have to keep going until they're all prime numbers. So I know 4 times 8 is 32. 4 is 2 times 2. And then 8 is one that you should remember. It's 2 times 2 times 2. Right? And then 10 also break down to be 2 times 5. So now all of these numbers here, right, are all prime numbers. So I know I can stop. And I'm going to put these numbers that I circled inside, right? So I'm going to rewrite my square root here, right? And I'm going to put these numbers inside here. So 320 is the same thing as 2 times 2 times 2 times 2 times 2 times 2. Right? We've got 6 2's there, and then times 5. Okay? But since this is, right, this is a square root, which means we have kind of a little invisible 2 there. It doesn't show us that index when it's blank there. It means it's a square root. And so that index is telling you how many of the same number do you need in order for that number to be able to come out of the square root, right? So we need 2 of the same. So this pair of 2's gets to come out as a 2. we've got another pair of 2's that comes out as a 2. And another pair that gets to come out. Right? And when they come out, they're multiplied together. But notice this 5 doesn't have anybody to pair up with, so it is stuck inside. It does not get to come out of that square root. All right, so we still have that square root of 5 here. But now let's simplify what we have on the outside there. So 2 times 2 times 2 gives me 8, and then the square root of 5. So 8 square root of 5 would be your simplified answer on this. Okay. All right, let's look at one now that has some variables involved with it. So let's do number 35. So 35 wants us to simplify. So we got 5a, so 5 times a on the outside, and then times the square root of 125a to the 4th power. All right, and again, remember, right, when it doesn't show the index there, it's a square root. So there's kind of like that little invisible 2 that's there, and that's telling you how many of the same number you need in order for it to come out. Right, so just like we did on the one above, let's go ahead and take the number 125 and let's write it as a prime factorization. So, 5 times 25 is 125. And if you didn't know that right off, remember that any number that ends in a 5 is divisible by 5. So 5 times something is going to give you that 125. So 5 is prime, but 25 breaks down to be 5 times 5. And remember, I know something is prime when the only thing that it could break down to be is like 5 times 1, right? 1 times that number. So I've got 5 times 5 times 5. Right? So that's going to go inside my square root there. So let me rewrite it on this line. So I've got 5 times a on the outside, and then square root of 5 times 5 times 5. And then I've got a to the 4th power, so that means I've got 4 a's inside there multiplied together. So a times a times a times a. And now again, remember, this is a square root, so I'm bringing things out, right, that are that has a pair, right? Groups of 2 is what I'm doing. And so I can see, all right, a 5 gets to come out, an a gets to come out, and another a gets to come out, right? So 5 and a get to come out, right? And when they come out, they're going to be multiplied by that 5a that's already on the outside. So let me write it this way. Make sure this is clear. So I'm going to keep that 5a that was already out there. All right. And then next to it, I'll write times 5 times a times a. Right? Those things that get to come out. But then still stuck inside my square root, this other 5 doesn't have anybody to pair up with, so it is stuck inside there. All right, but now I've got to simplify the stuff on the outside. And remember, whenever anything comes out of the square root, you're going to multiply by anything that's already out there and multiply together. So I've got 5 times 5, which is 25. A times a times a, which is a to the 3rd power. And then that square root of 5. So that would be my answer, my simplified answer on there. When you're simplifying, you're just trying to figure out what is inside the square root, right, that has a pair that could come out. All right, let's look at number 38 also. This one we've got a fourth root, right? So let's make sure we know what to do if we have a fourth root. All right, so again, we're going to simplify. And we've got 3 times the fourth root, right? So notice this gives us a different root. It's not a square root, it's a fourth root of 80. Right? And so again, we're going to take that 80 and we're going to find its prime factorization by making a factor tree. So I know 8 times 10, right, is 80. 8 breaks down to be 2 times 2 times 2, and 10 is 2 times 5. Right, so let's rewrite that over here. So 3 is still on the outside. The fourth root of 2 times 2 times 2 times 2 times 5. Right? Now notice this time we've got a fourth root, so that means things have to come out in groups of 4. Right? So I can see, oh, all right, I've got a group of 4 right here. I've got 4 2s. So those 4 2s are going to come out just as a 2. All right, but 5 would need 3 other buddies, which he doesn't have, so 5 is stuck inside. All right, and when 2 comes out, remember it's multiplied by the number that's already out there. So we're going to have 3 times 2 is 6 on the outside, and then square root, nope, sorry, not square root, fourth root of just 5. That's what's left in there. So 6, fourth root of 5 would be your answer on that one. Okay, and it's really easy to accidentally forget that little index there, especially when you've been working with square roots quite a bit and you just leave it blank there. But be really careful in that, because on the test and on the quizzes and stuff, you will miss points if you forget to put that root, if it's something other than a square root. You've got to have that index there, okay, to tell us what kind of root it is. All right, so let's see here. Where do we want to go now? So that was number 38. Let's go down. Let's do some off of 5.6. 5.6 is where we talked about the Pythagorean Theorem. And remember, the Pythagorean Theorem says a squared plus b squared equals c squared, where a and b are the legs of a right triangle, and c is the hypotenuse. And the hypotenuse is always the longest side, and it's the side that's opposite the 90-degree angle. Right? So number 40 is a story problem. And so with this kind of problem, I'm going to want to look at this and try and draw a picture of what's going on here. Okay, so it says a 12-foot ladder is placed against a building. If the base of the ladder is 4 feet away from the building, how far up the building will the ladder reach? And then we want to make sure we round our answer to the nearest tenth. Okay, so let's draw a little picture of it. So here's my lovely building, right? La 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 la. Okay. Put little windows and stuff so you can see. This is a gorgeous building here, right? And so we have a ladder that's going to be up against the side, right, of it. And it tells us that this ladder is 12 feet long, right? So we know that that's what this is. Actually, let's see, maybe I'll make it look a little bit more like a ladder, right, by going like this, right? So that means that this is 12 feet, right, along that side there. Right, it's a 12-foot ladder. Then it also tells us the base of the ladder, so that's down here, right, is 4 feet away from the building. So here's my building, here's the base, so we know it's 4 feet from here to here. And then we want to figure out how high up the building this is going to reach. right? Well, remember I said that the hypotenuse is always going to be the longest side, right? And that's 12 feet. So we know our answer is going to have to be less than 12 feet. And think about it, I mean, if you thought of just in your mind, a ladder, if it was flush right up against the wall, it would reach 12 feet. But if you drag it further out from the wall, it's not going to reach up as high, right? Okay, so I'm going to call this side B. It's just one of the sides, right? It could have been A or B, but our hypotenuse, right, has to be that 12. All right, so let's plug in what we know here. So I'm going to put 4 in place of my A, so I've got 4 squared. And then B, that's the side I'm trying to find, so plus B squared equals C, which is 12, so 12 squared. So let's simplify what we have here. So we've got 16 plus B squared equals 144. Remember, 12 squared, you're doing 12 times 12, not 12 times 2, right? And so now we're going to do 144 minus 16 because we're trying to get the letter, that variable there, by itself, right? So let's subtract the 16 over, and then that will give us B squared equals 128. And then when we're thinking about, okay, we don't have B by itself yet. That's what we're trying to solve for. We're trying to figure out what B is. But to undo squaring something, we square root both sides, right, of the equation. So when we do that, right, squaring something and square rooting are opposite operations, so those undo each other, and then you're just left with B on this side, right, which is what we want. And then if you figure out on your calculator, what is the square root of 128? And it wants us to round our answer to the nearest tenth. All right, so make sure you're rounding to the place that it's asking you to round to. Notice that carefully because that tends to be something that people miss on the tests. It's just the rounding. So it says 11.3137, blah, 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 right? It keeps going. But we want to round to the nearest tenth, so that's here, and 1 is not big enough to round that up. So we'll have our answer is 11.3 feet. And that seems reasonable because we said we knew it was going to be less than 12 feet because that's how high up that ladder will reach, right? But, but it's not too far away from 12 feet either, right? So that seems a reasonable answer. All right, so that's how you deal with the Pythagorean theorem, all right, and some of the story problems that are there. Let's go to 5.7 and talk about some things with polynomials. So on 5.7, let's do number 41 first. So I want to make sure that everybody knows the different parts, right, of our polynomial. So they give us this polynomial, 8x to the third power plus 2x to the second power minus 7x plus 4. And then it wants us to find a few different things, right? So it wants us to find the leading coefficient. And so the leading coefficient, so you got to make sure that your polynomial is written in descending order, which means your first term has the highest exponent, then the next one has the next highest, the next one has the next highest, and so on, right? And the coefficient is the number, right, that's out in front of that x to the third term. So our leading coefficient is going to be 8. Then the next thing it wants us to find is the constant term. So the constant term is the one that doesn't have a variable with it. right? So 4 is going to remain constant. That term is always going to be 4. Where if we looked at the one in front of it, this term isn't always going to be negative 7. It depends on what x is and what we multiply that together. But 4 stays constant because it doesn't have a variable next to it there that we're dealing with. So our constant term is just 4. And if that said a negative in front of there, then we'd put our constant term would be a negative 4, right? Whatever sign is out in front of it sticks with it, right? Then the other thing that it wants us to find is the degree of the polynomial, right? And so the degree means, for what we're going to be dealing with on this one, we're just looking for the highest exponent on here. And so our highest exponent is 3, so that means our degree is 3. Okay, so those are some different parts of polynomials that you should know and get familiar with, making sure you know what I mean when I say the leading term or the leading coefficient or any of the coefficients, and the constant term and the degree. All of those things are going to be words that you're going to hear a lot of. All right, let's look at 43 now. 43 wants us to combine the like terms together. All right, so combine like terms. And like terms are ones that have the same variable with the same exponent on it. So like x and x squared are not like terms. X squared and 3x squared would be like terms. Okay? So if we have, so it gives us negative x to the third minus 12x to the second minus 9 minus 12x to the fourth plus 11x to the third plus 9x plus 4. All right, so we've got a lot of different terms here. Some of them have terms that we can combine together, and some there's nothing to add with it, so we'll just leave it like it is. So we want to write things in descending order. So I'm going to look through here and notice what my highest exponent is. Not my highest coefficient, but exponent, right? So my highest exponent is this x to the fourth power. So I want to put this term very first. Okay, so let me do this. I'm going to underline this, right? And there's no other x to the fourth power, so I don't have anything else to combine with it. So I'll start off writing negative 12x to the fourth power. All right, then let's go the next degree down, right? So now I'm looking for something x to the third power. Well, I've got here, remember there's like an invisible 1 here, so it's saying negative 1x to the third and 11x to the third. So negative 1 plus 11 gives me a positive 10, so I'll have plus 10x to the third. All right, now let's go the next exponent down. So that would be x squared. So I've got a negative 12x squared, and there's no other x squared term here. So again, this is going to just be kind of part of our answer there, right? So we'll have minus x, minus 12x to the second power. All right, let's keep going. And let's go to the x terms now, right? And again, there's only one x term here, and that's just the 9x. So that becomes my next one that I write down. So plus 9x. Right? And then I have my last terms that I'm going to be combining together, my constant terms. So my negative 9 plus 4 will give me a negative 5. And so now all of those together are going to be my answer for combining those like terms together. All right, also in 5.7, we want to talk about how to multiply polynomials together. So let's look at number 47 next. And number 47 says a plus 5b in one parenthesis, and then 2a minus 7b. And so on this one, you're using FOIL, right? F-O-I-L. And so, yeah, some people use that little acronym to help them remember how to multiply these two binomials together. So remember to do this, you're going to take, and the F in FOIL stands for first, right? So we're going to do our first term. Oops, let's do this different. So our first terms, which is a times 2a. So a times 2a is 2a squared, right? I'm just multiplying those two together. Then we're going to do our outside term. So the O in FOIL stands for outside, or outer, however you want to think of that. And then we're going to take our outside terms of each of those binomials and multiply those together. So a times negative 7b gives us negative 7ab. Right? So we've got an a and a b that we've got there. Right? Then let's do our I in FOIL stands for inside. Right? So our inside terms would be 5b times 2a. So 5b times 2a is a positive 10ab. And then the L in FOIL stands for last, so that means the last terms of each of those binomials. So 5b times negative 7b, which gives us negative 35b squared. Right? And then we just want to combine any like terms together that we have. And so I can see that my two middle terms are like terms because they're both ABs. Right? And so when I write down my answer, I'm going to keep that 2a squared, combine those middle terms together. That'll give me plus 3ab, right? Negative 7 plus 10, and then minus 35b squared. And so that would be your answer. So you're going to multiply those and then simplify just by adding any like terms together that you have there. Okay? So let's look at 48 also, because this one looks a little bit different, but it's really the same idea of what we're doing here. So it wants us to multiply 3a minus 4 all squared. Well, remember, when we have something squared, that just means that we're going to take that something and multiply it by itself. And then you can see again, this is just a FOIL again. All right, so we'll start with our first terms. 3a times 3a is going to be 9a squared. Then we'll have our outside terms. That will give us negative 12a. Multiply those together. Then we'll have our inside terms, which is another negative 12a. And then our last terms. Right? Negative 4 times negative 4 is a positive 16. And now, again, we're going to combine those like terms together. Right? So that means we're going to have 9a squared, negative 12 plus another negative 12 is a negative 24a. All right, remember, they have to be like terms to combine together, and so it stays as an a. Right? Don't change that to an a squared. Got to be the same, and then you write it down just as an a. And then plus 16. And that would be your answer there. Okay? So that's just foiling those, multiplying those together that way. Okay? And then the last section in Module 5 is 5.8, which is factoring. And basically, factoring is just undoing what we just did. So taking, our answer that we started with and work backwards to get to our factored answer. Okay? So the first one I want to look at is number 50. And on this one, it wants us just to factor out the greatest common factor. Okay, so factor out the GCF, the greatest common factor. And that, so it gives us negative 35x to the fourth, negative 15x to the third, minus 5x squared. So you first want to start off with the number part, right? So we're looking at negative 35, negative 15, and negative 5. And we want to figure out what is the largest number that can divide into each of those, right? And that would be negative 5. So negative 5 is going to be part of our GCF. Now we've got to look at the variables, right? The x's here. And now I'm trying to think, okay, what is the largest, right? What's the greatest common factor of x to the fourth, x to the third, and x squared, right? And x squared is going to be our answer because it's, and this kind of throws people off with the GCF, but when you're thinking of the GCF, right, you're thinking of what's the largest number that will divide into it. Well, x squared is the largest variable that can divide into those because this guy only has an x squared to give, right? So maybe another way you can think of it is it's always going to be the smallest exponent, right? The variable with the smallest exponent is going to be part of your GCF. Okay, so negative 5x squared is my GCF, and then in parentheses next to it, you're going to write your leftovers, because what you're basically doing here is you're dividing each of these terms by negative 5x squared. All right, that's what I mean by factoring it out. It's really division that's happening there. So if you try and simplify this first term, well, negative 35 divided by negative 5 is 7. X to the fourth divided by x to the second is x squared. All right, remembering our properties of exponents, that if we had, you know, when it's connected by division, we subtract those exponents. Okay, then on the next term, negative 15 divided by negative 5 gives us a positive 3, and then x to the third divided by x squared is just an x. Right? Now let's keep going here, right? So this last one, and this is where some people get a little bit tricked here, right? What is negative 5 divided by negative 5? Well, that's a positive 1. Remember, anything divided by itself is just 1, so you need to make sure that you put that 1 here. Right, and then x squared divided by x squared is also a 1. So maybe I'll write it this way, right? So negative 5 divided by negative 5 is a 1. X squared divided by x squared is a 1, but you're really doing what's 1 times 1, right? Which gives us this 1 here. And so that 1 is an important part of our answer, because remember, to check this, we would distribute that negative 5x squared to everybody. And when we do that, we better end up with what we started with, because we're just undoing that process, right? Factoring and multiplying are just undoing each other. All right, so that would be your answer on this, factoring out a GCF. Okay. Also in 5.8, we talked about factoring some trinomials. So let's look at 52 next. So 52 says it wants you to factor x to the second minus 9x plus 18. And so when we have a trinomial that we're trying to factor, we're going to be writing down two binomials. Right? So I'm going to get my parentheses already set up. So remember, it's kind of like undoing this process here. We start with this, and we're going to end up with something that has those two parentheses there. So first thing we're going to look at is that x squared. What times what is x squared? Well, that's x times x. So that's how each of those are going to start off. And then you're going to ask yourself what multiplies to be 18, right? So what multiplies to be 18 that adds to be -9. So you're trying to think of all the factors that you can of 18. All right, so let's work organized and go, okay, there's 1 times 18, there's 2 times 9, and there's 3 times 6. All right, and we can't go, and there's nothing any further because there's not a 4 times something that's 18, there's not a 5 times something that's 18, and then we're back to the 6 here. So these are the only factors. So now I'm trying to think, how could I add or subtract these numbers together so that I end up with a -9? Well, I'd have to have my 3 and my 6 both be negative, right? So -3 times -6 gives me a +18, and -3, let me do that in a different color. Let's do -3 plus a -6 gives you that -9, right? So what multiplies to be 18, that adds to be -9. So those are the two numbers that we're going to be putting inside our parentheses now. So we'll have that -3 and that -6. And so our answer is, in one parenthesis, x minus 3, and the other parenthesis, x minus 6. And it doesn't matter which one you write first and which one you write second. So if you wrote your answer as x minus 6 times x minus 3, still a perfectly good answer. Okay, doesn't matter which order you put it in. All right, let's go to 56. I'm going to do just a couple more here so we can finish up this little review. So on 56, again, we're going to be doing some factoring. And when you have a trinomial, right, you do want to make sure that you're looking to see if there's any kind of a GCF, like a greatest common factor, that you can divide out first. Right? So on this one, you can see each of our terms, they don't have a coefficient that can divide out, but you can see that each of them have an x that can be divided out. So we've got to take that x out in front first, right? And when I divide each of these terms by x, the left-hand side will be x squared plus 3x, and then minus 40. And then we want to look at this trinomial and see if we can break it down like we did here on 52. Okay, can this factor any more? Well, x is still part of our answer, so don't forget about that. And then write 2 sets of parentheses here. All right, let's think about what we're going to do here. So x times x gives me that x squared. Then what times what multiplies to be negative 40. Right, so multiplies to be a negative 40 that adds to be a positive 3. Right, so what multiplies to be negative 40 that adds to be 3. So we can think, well, and so if we have a negative number, right, to get a negative number by two things multiplied together, one has to be a positive and one has to be a negative. So I'm not going to put the negatives on right now. I'm just going to do these as positive numbers, and then we'll decide where those negatives need to go. So meaning 1 times 40 is 40, right? 2 times 20 is 40. 3 doesn't divide into it. 4 times 10 is 40. And then 5 times 8 is 40. And so now I'm going to look at these and say, okay, is there any way if I add or subtract these factors that I would end up with a positive 3? Well, if I look at this last one here, right, if I have a negative 5 and a positive 8, right, negative 5 times positive 8 is negative 40. And then if I have a negative 5 plus a positive 8, that also equals 3. Right? So negative 5 and positive 8 are the numbers that I want to put inside here. So x minus 5 and x plus 8, because it's a positive 8. And then all of this is your answer. There it is in factored form. And factored form just means that everything is connected together by multiplication. Okay? All right, let's do one last one here. And we'll stop there, and then remember you can work back through any of these other ones. You know, whoops, what am I doing? Not 5.7, 57 is what I wanted to do. Okay, so number 57 asks you to factor x squared minus 7x plus 30. All right, so again, it's a trinomial. So I'm going to try and break it down to two different sets of parentheses. What times what is x squared? That's x times x. What times what is 30? That adds to be negative 7. Right? So what multiplies to be this last number, positive 30, that adds to be that middle number. So again, we've got to think of all of our possibilities. But what times what is 30? And you want to make sure that you work organized to make sure that you get every single possible pair of factors that could come, right? So that's why I always start with 1 times that number. 1 times 30 is 30. Then move up and say, can 2 divide into that? Yep, 2 divides into it 15 times. So 2 times 15 is 30. All right, then 3 will divide into it. 3 times 10. 4 doesn't go in evenly. 5 will divide into it 6 times, and then we know we're done. We've got all of our factors there. And so if we look at these and we're trying to think, okay, is there any way that I could add or subtract these to be, right, a negative 7 there in the middle, right? That's what we're trying to look at here, if there's any way that we can do this, right? So some people think, well, what about this 3 and 10, right? Well, if I make one of these numbers negative, right, so if I made that a negative 10, then 3 times negative 10 gives me a negative 30, not a positive 30, right? When I add those together, right, I do get a negative 7, but I don't multiply to get a positive 30. And there's no other way, right, that I could possibly get something to multiply to be positive 30, add to be negative 7. So that means that this does not factor. And when something doesn't factor, we call it a prime polynomial. Right? So it's prime, and that's how we'll put our answer, meaning it does not factor. Right? Because remember, we can't have this 3 times negative 10. That means that this would have had to say x squared minus 7x minus 30. But that's not what it says. It says plus 30. So we need something that multiplies to be a positive 30. Okay? So that doesn't work there. All right. Well, I hope you find this helpful as you're going through the Module 5 and with any of those that you have questions on. Remember, if you have other questions, please reach out to me for some individual help. I'm always here to help you with these problems, and I want to make sure that you are understanding them and get any of your questions answered. Okay? Thank you so much.